Hello, welcome to Maths with EJD. Again, I'm making a video on one aspect of scientific computing, and we've been talking about NumPy for some time now. So I'll navigate my way there. Okay, having shared my screen, the next thing is to start Jupyter Notebook by going to my search box, and then the terminal comes up. So once that is done, you have something like a web page coming up. It's like a web page, but it is actually not internet is not necessarily required for this. And then you navigate to the folder where you have what you are looking for. And mine is scientific computing on a desktop. And today we are going to the 11th video, which talks about array manipulation and shape operations. All right. Straight to the point. Of course, if you have not subscribed by now, you'll be missing a lot if you don't do that. And of course, you don't forget to hit the notification bell so you can always get alerted each time a new video is released. Array manipulation and shape operations. Array manipulation and shape operations. Array manipulation and shape operations. They are fundamental techniques in programming, particularly in fields like data science, machine learning, and numerical computing. So these operations involve altering the structure or content of arrays, which are data structures consisting of elements arranged in a grid or matrix. Of course, in our previous video where I talked about Python variable data structures, we already have an idea what the data structures are, especially since we came to NumPy, we've been using lists a lot. List is one of the arrays which are ordered and they're also mutable. Ordered, because they're ordered, you can index them, and because they are mutable, you can add to them, remove from them, or replace things there. So, and since we've been working with NumPy, we've seen a lot of cases where we create a NumPy array by using a list, a Python list, or if you want to create like a two-dimensional array, you use a list of lists. So in array manipulation and shape operations, the first thing we are considering is reshaping. So you want to reshape whatever you have. So you have here that reshaping arrays involves changing the dimensions while maintaining the total number of elements. So here, of course, since you're dealing with NumPy, right? I mean, if you have forgotten, don't forget NumPy is numerical Python, and it is very good when you have to use when you need to do use arrays or matrices. So NumPy is your go-to package, your go-to library. But anytime you have to deal with arrays, especially complicated arrays, two-dimensional arrays, because under Python lists, for instance, it's just one-dimensional. Okay, so here, let me put the view so we can have the show line numbers, so I can refer to the lines. So import NumPy as NP. That's you activating this until you run it, and a number shows at this left-hand side or so. You have not registered it. So, and then of course, line 3 is where you declare your NumPy array, and this NumPy array is actually going to be so you have a list of lists here. So you're going to have like so this is row 1, row 2, row 3. So you're going to have 3 rows and 2 columns, right? So you're going to have a 3 by 2 matrix. So if you want to reshape a 3 by 2 matrix, it means you can make it into a 2 by 3 matrix and all that. So line 3, you declare the 3 by 2 matrix. And in line 5, now you're reshaping it into a 2 by 3 matrix. And the keyword here is the reshape keyword. So, and the reshape keyword is actually a function that you find inside the NumPy library. And then, of course, you call the array, which is the variable, the array name in line 3. So you call the array and then you say, make it 2, 3. In fact, for you to appreciate what is happening, let's print the original one. Print ARR. So print ARR. And of course, I like to put a blank print so that we can have space between the two. So here now, line 8, what has become line 8 now is reshaped underscore ARR, and then that'll be np.reshape. Then, so it's a 3 by 2 matrix is now being reshaped into a 2 by 3 matrix. And that is the idea of reshaping. So you see, the first matrix is 3 by 2, has 3 rows, 2 columns. And here you have reshaped it into 2 rows, 3 columns, like that. Okay. So, so don't forget that whatever you are reshaping into, for instance, you have 3 by 2 here. So any other thing you're going to get should actually follow the same number of elements. If not, it will be out of order. To be out of order. Okay. So, okay, I want to try something out. Let me see if this works. What if we try to get a 6 by 1 matrix? I want to be sure if that works. Let's see. 6 by 1, because 6 times 1 is also 6, except if it works for only NumPy. Yeah, that works exactly. That works. So you can make a 3 by 2 matrix into a 2 by 3 matrix. You can make it into a 6 by 1 matrix. You can make it into a 1 by 6, I'm sure. You can make it into a 6 by 1 matrix. I mean, a 1 by 6 rather. So that's 1 row, 6 columns. Here it's 6. I mean, this is 6 rows, 1 column. So 1 by 6 makes it into 1 row, 6 columns. So interestingly, whatever you start with, if you start with 3 by 2, then you can make it into other possibilities that will, when you multiply them out, it gives you the same 2 times 3, 6. So next we go to flattening. Flattening an array means converting a multi-dimensional array into a one-dimensional array. So that's it's like you're removing the shape, you're making it back into like a normal Python list, right? For instance, if you want to flatten array, right? So you have flattened array will now be equal to arr.flatten. And don't forget, your original ARR is this line 3, this 3 by 2 matrix, So to flatten it, it means you're making it into. Oh, in fact, that is going to be like when you're reshaping it into 1 by 6, I believe, because you're just making it into a Python list. So you can flatten any array that way. Okay. So that leads us to transposition. Of course, transposing an array involves swapping its rows and columns. So when you transpose an array, you're making the rows the columns and you're making the columns the rows. This is often useful for matrix operation. So if you check my playlist on matrices, there I discuss the idea of transposition of matrices, and that comes very useful in some matrix operations like you see. All right. So here, the same array, right? The same 3 by 2. Don't forget the ARR. Now, once you declare an array somewhere, or in Python, right, you can declare something in the first line and you keep using it all the way down. So even in the 1000 cell, you can just call that and you don't have to repeat it, because as far as you don't create another thing with the same variable name, so that it will always be available to you. So for instance, we know that okay, of course, this is just going to be like you reshaping it into a 3 by 2 matrix into a 2 by 3 matrix, I believe. That's exactly what it's going to be like. So I mean, so it means you can do so to some operations. It can, if you have a reshape equivalent of a flattening of a transposition thing, right? So that's one thing about transposition. So the rows becomes the columns become the rows, basically. And then, of course, we can have concatenation. Concatenation, of course, whether in chemistry or programming, concatenation simply means joining two or more things together, basically. So here we have new sets of arrays. So concatenated arrays combines them along a specified axis. For instance, you have array 1, in line 1, you have array 1, which is 1, 2, 3, 4. So that's a 2 by 2 matrix. Array 2 is also a 2 by 2 matrix with 5, 6, and 7, and 8. So if you concatenate, so the concatenated array now will now be NP. The keyword here is concatenate. So NP concatenate. That means you're bringing concatenate from the NumPy library. So you're concatenating array 1 and array 2 along the 0 axis. So let's see what that gives us. So here it's stacking them on themselves. So I notice it's about axis. Let's experiment with other axis. Let's see what we get. Okay. Well, I don't have to bring all of this. All I need is these lines 4 and 5, since all the array 1 and 2 have already been registered. So what if I do it along axis 1? All right. So along axis 1, see what happens. So it's axis 0 means it will just stack them on themselves. 1, 2, 3, 4, 5, 6, 7, 8, like with each one a row. But when you do axis 1, right, so it takes 1, 2, 5, 6 in one row, 3, 4, 7, 8 in another row. All right. So it takes it this way and that way. So let's see what happens with axis 2. Let's see what that does. Okay. This now I say axis 2. So if you do axis 2, what happens? Okay, I mean, axis 2 is out of bounds for array of dimension 2. Nice. So since it's array of dimension 2, that doesn't work. But let's see. Okay, we are okay. So for axis for dimension 2, we can only do 0 and 1. Okay, yeah, that's what that would mean. So we are done with that. Okay, so we can talk about splitting. Splitting, of course, you know what it means to split something. If you concatenate something, you can actually split it. Splitting an array divides it into multiple smaller arrays. For instance, you have the same array. Don't forget this concatenated array. We had it here. Concatenated array. Okay, I think I've done something else. Okay, let me bring this back so that this will be the registered thing. This way. All right. So this is, so, since I have another concatenated array here, this is the most recent one. So I'm bringing this back so it can work with what we have now. Okay. So splitting, so we want to split that concatenated array into two along axis 0. So if you do this, see what you get. So it breaks it down into, it breaks it down into two parts. That's 1, 2, 3, 4. That's one array. 5, 6, 7, 8, another array. But then we can check, let's see, here we bring this and say, well, because it has 4 rows, right? It has 4 parts. I'm not sure we can break it into 3. I don't think so. Yeah, 3 doesn't work. 4 should work. 4 can work. So in the case of 4, so it breaks it down into, so 1, 2 is an array, 3, 4 is an array, 5, 6 is an array, 7, 8 is an array. So we have to do only multiple possibilities of what we have. Like, since you have 4, you can do 2, you can do 4. I'm sure we cannot do more than this now. So let's look at the axis. What if I make this one 1? What happens? Okay, so it makes it 1, 3, 5. Okay, in fact, that should be something different, right? Let me undo that and do this separately. So if I bring this now, so we are doing a split of 2 in axis 1, all right? So see what that gives. So that breaks it into 2, and you have 1, 3, 5, 7, and then 2, 4, 6, 8. 1, 3, 5, 7, 2, 4, 6, 8. That's 1, 1, 3, 5, 7. So you're taking just the first element, 1, 3, 5, 7, and then 2, 4, 6, 8 as the second one. So that is you splitting the concatenated array into 2 along axis 1. I think we cannot go axis 2 just like what we saw before. So let's do this along axis 1 and see what we also get. So, we are talking about shape operations. So that's what we are doing here. So here, okay, am I still here? Okay. Okay, axis 1. So this is, so is 3 giving us this now? No, 3 won't work. So it should be 4, sorry. So 4 give us that, right? So then I do 4 here along axis 1, all right? And then we split. Oh, okay. It doesn't, array split does not result in an equal division. All right, so this doesn't work. So we just forget about it. Okay. All right. So this goes. Yeah, so let's talk about resizing. Resizing. So we are talking about array manipulation and shape operation. So it is you reshaping the array you have as you like it. And this can be useful when you're writing, when you're doing any kind of project that will require some manipulation like that. So resizing arrays changes the shape and potentially the size of an array. I think we've done something like this previously. So I mean, this is actually interesting, especially if you don't care what the elements in your array are. So for instance, you have in line 1, you have an array created by a list of lists, which is actually fundamentally a 2 by 2 thing. Okay, in fact, let me print that as usual so you can see what's happening there. So just print ARR. Then, of course, it's very important to always put a blank print to give space so you can see what is happening. Then the resized array now is the resize. You are resizing that array into a 3 by 3. So what is going to happen here is that it's going to go along 1, 2, 3. That's one row. 4. So you have a 3 by 3, right? 1, 2, 3. Then 3. 1, 2, 3, 4, 1, 2. So it will just keep iterating over the 1, 2, 3, 4. Whatever you give it, that's what it iterates over. So you see this. So what you have is 1, 2, 3, 4. But here, because you want a 3 by 3 matrix, so you have 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3, 4, 1. So it keeps going over the numbers like that. For you to have a better understanding of this, we can actually make this same thing into a 4 by 4 matrix. The only thing is that it just takes all the numbers. And of course, I believe it doesn't have to be a square matrix too. It can be, for instance, we can make it into like a 5 by 7 matrix. Let's see how that happens. 5 by 7. If that doesn't work, then we know it won't work. So 5 by 7, yeah. So it just keeps running over the numbers. So you have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. So it just keeps taking the numbers like that. So you can actually reshape. So this deals with a whole lot of flexibility. And finally, let's talk about mesh grid. Mesh grid is used to create coordinate matrices from coordinate vectors. So let's see what's happening here. So you create in lines 1 and 2, you create two arrays. You create two arrays from two Python lists, 1, 2, 3, and 4, 5, 6. Then you have big X comma big Y, and you say np.meshGrid. Meshgrid is the function here you're bringing from NumPy library, and then you have X comma Y here. So then, so we're printing X and we're printing Y. Let's see what that gives. Let's see what that is. Okay. So if you're printing X means you're saying this 1, 2, 3. So for X now, 1, 2, 3 just repeats 3 times. But for Y, when you print Y, it is repeating this 4 here, 1, 2, 4, 3 times, 5 here, 3 times, 6 here, 6 times. So it means for the X part now, it means that whatever you have at the top, the whole row is repeated thrice. But for the Y part, the whole each number is repeated thrice. Okay. So for X, the whole row is repeated 3 times. For Y, each element in Y is repeated 4 times to form a row. So for better understanding, what I did, here we have X comma Y, right? So for you to have a better understanding, again, I'm doing so the same X and Y, right? But here I have swapped the Y and X instead of X and Y. So you have Y comma X equals np.meshgrid Y comma X. So now Y is coming first. So it means that what we expect here is that what happened to Y before should happen to X now. So now our X is going to be 1, 1, 1, 2, 2, 2, 3, 3, 3, while Y will be 4, 5, 6, y will be 4, 5, 6, 4, 5, 6, 4, 5, 4, 5, 6. And let's see that exactly what happens. Okay, so with this, we have come to the end of this particular video. Don't forget, you have the notes, the link to the notes you can find in the description. So you can download even before you start following through. So thank you for coming by. Don't forget to subscribe, hit the notification bell so you can get alerted when a new video is released. And of course, don't forget to comment, share, and like. Thanks for listening. See you in the next video.